Okay, we're looking today at E, okay? On page 387. First of all, where do you find the button E? On your calculator. Where is it? Second division symbol? Okay. On page 387. Before we even start today, let's talk about some buttons that you have on your calculator. Now, everybody identify the log button on your calculator. The log button. I'm just going to write it up here. Let's review some logs. See the log button? Everybody type in log 10, K equal. It shows you 1. Okay? Yes? Yes. Okay, log of 100. It should show you 2. Log of 1,000. 3. Here's why. We have a base. What this means is it's asking us, there's actually a number 10 sitting right there. So it's actually saying 10 to the first power is 10. This one is saying 10 to the second power is 100. This one is saying 10 to the third power is 1,000. Because the base on the log button on the calculator is base 10. It doesn't show that, but it's called a common log. Okay? It's called a common log. The button right below it looks like that. Okay? That is the natural log. That is the natural log. So the letters are backwards. Okay? And what that is this has a base of E. Okay? It has a base of E. So if I wanted you to compute the ln of E, why don't you do that? Take the ln of E, hit equals. It will show you the number 1. Here's why. The natural log has a base of E. So this is actually saying E to the first power is E. What's the ln of 8? Well, all you do is take an ln of 8, and it gives you a number that's approximately what? 2 by what? 0.79? Now, do this for me. Call up E, so go second division symbol, get E in your calculator, raise it to the power of the answer. Equals 8. Because this is actually saying E to the power equals 8. Okay? On your ACT, you might see problems like this. Log of 27, base 3. What is it asking you as an exponential equation? It's actually asking you three to some power is 27. What's the answer? 3. So this answer is 3. The log of 27 base 3 is 3. Why? Because 3 to the third is 27. Okay? What's the log of 8 base 8? 1. I'm going to keep going until you guys get this. What's the log of 64 base 4? So 4 to the 4th is 64? You sure about that? It's 3, right? This is 3. Log of 36 base 6. 2, good. One more. Log of 16 base 2. So what you're doing in your heads, when I say logs, you're thinking exponentially, right? You're saying 2 to what power is 16? 4, that's the answer. You said 6 to the second power is 36, okay? That's logarithms, that's the log button. If it's the natural log, it's the ln button, okay? What's the base of the common log again? That you don't see, it's 10, it's base 10. What's the base of a natural log? E. It's E. So go to page 389, table 1, please. We have an expression of 1 plus 1 over x taken to the power of x. Okay? If we let x be 1, of course, we get 2. If we let x be 10, we get 2.593. If x is 100, we get 2.704, and so on. It says, by calculating the value of 1 plus 1 over x to the x power for larger and larger values of x, it looks like the values approach a number close to 2.7183. In a calculus course, we can show that as x increases without bound, the value of 1 plus 1 over x taken to the x power approaches an irrational number that we call e. Just as irrational numbers such as pi and the square root of 2 have unending, non-repeating decimal representations, e also has an unending, non-repeating decimal representation. To 12 decimal places, e is approximately 2.7182818288459. It is a number located between the square root of 2 and pi. Don't let the symbol e intimidate you. It's just a number. It's a famous irrational number. Exactly who discovered E is still being debated. It is named after the great Swiss mathematician Leonhard Euler, 1707 to 1783, who computed E to 23 decimal places using bracket 1 plus 1 over x, close brackets, to the x power. The constant E turns out to be an ideal base for an exponential function because in calculus and higher mathematics, many operations take on their simplest form using this base. This is why you will see E used extensively in expressions and formulas that model real-world phenomena. Science and math, the number E gets used a lot, especially in something like banking, okay, which we're going to see today. So, when you hear the word E, you should think of the natural log. Okay? The natural log is base E. So looking at your notes today, we want to know that E from now on is approximately 2.7183. That is a number that all of us will know. Just like pi, we got 3.14. We know now that E is this number that Leonhard Euler in 1707 and 1783 said it's going to be some irrational number that's going to approach the number 2.7183. All right. Number 3. Describe the graph of f of x equals 2. Now this is raised to the power of x over 2 minus 5. So everybody put that in your calculator. I have written it, and I've copied my screen for you. This is how it's got to go in. Okay, so I took a snapshot of the screen. Okay, then you should get the table. And then you should get a picture. Do you have that? Okay, so looking at your graph, I want you guys to answer these questions and be able to do this on your quiz. Right here. Is this function considered an increasing or decreasing function? Increasing. Okay. This is an increasing function. As x approaches infinity, y gets bigger, and so on. So it's increasing. Let's talk about the behavior. As x approaches infinity, f of x approaches what? Infinity. As x approaches negative infinity, f of x approaches what? Look at your graph. Look at your chart. Scroll up to where x is getting smaller and smaller and smaller. Keep an eye on the y sub 1 column. What's it approaching? Negative 5? Negative 5? Very good. So the next question to ask is there a horizontal asymptote? What is it? Good. Why would I say it's incorrect to say the horizontal asymptote is negative 5? It has to be an equation. Yep. Okay. Next thing. Looking at your graph, is this function continuous or discontinuous? It's continuous. Tell me what the y-intercept is. Where does the graph cross the y-axis? Well, what do I plug in for 0? Or for x? 0, right? Look at the table. When x is 0, y is negative 3. Isn't that the y-intercept? 0, negative 3. And lastly, tell me what the x-intercept is. How are you going to find the point at which it crosses the x-axis? Calculate 0, left bound, right bound, guess. Somebody have the approximate root? Good, excellent, 1.83, comma 0. Very good. So if I give you a problem on a quiz, that would be a good problem to give you when I ask you all those questions. And that should be pretty easy to do right now. Okay? Any questions on that? Before we shift gears? Nothing in blue causes a problem? All right. Let's move on to real life. How is this pertaining to real life? Well, we're going to talk in this section about some interest, some banking, the number E. Okay? First formula, I'm going to have you guys put on a note card, okay, because you're going to have to know it, is the formula for compound interest. Okay? And the formula is A equals P times the quantity 1 plus R divided by N raised to the NT power. What you need to know is what do all the variables stand for. So first of all, A is the amount after time T. That's your dollar amount. Capital P is the principal, that's the original amount. N is the number of times you compound in a year. And T is the time in years. Okay? You guys ever seen that one before? That formula? You have? Some of you have, some of you haven't. Real quick, banking 101. When you go to the bank and you ask for a loan, what's kind of the premise of the loan? What are the conditions of the loan? Do you know? First of all, you have to tell them what you want to borrow for, right? And how much you want to borrow it. And then what's important to you when you go get a loan when you're 18 and go buy something for college? What's the interest rate? So the interest rate is important. How long you're going to have the loan for is important. Okay? So the time of the loan and how much you're going to borrow. And then how does the bank make it affordable to you? Wouldn't they just offer you to stretch the loan out? Because the more they stretch the loan out, from a 5-year loan to a 6-year to a 7-year loan, what happens to your payments? They go down, which makes it more affordable for you. But what's wrong with that on the flip side? The longer you take it for, the more you're going to pay in interest. So if your parents bought a house, or you buy a house when you're 25, probably what are your two choices for how long you want the loan for? 12, 15 would be one option. Sometimes you get it for 20, but probably the most popular is 30-year loan. So when you're 55 years old, let's say, you would own your house. Do you want to make any predictions on how much you'll pay on your $200,000 house, Taylor? When you're done after 30 years, you borrowed $200,000. Do you want to guess how much money you'll pay the bank? How much? A lot? You want to be more specific?
After how many years?
30. You borrowed $200,000. Don't say 195,000. Huh?
Paid more than that.
Paid more than 200,000? Yep. Do you guys have any idea? 350,000? Good guess. Yeah. Probably more than that. Probably like $450,000. Now you're going. I only bought it for 200,000. Yeah. Probably doubled. So you're done for 30 years. You have your mortgage burning ceremony. You're fired up. You own your house. And you probably would have paid probably double. Can you guys even wrap your 17-year-old minds around that concept? It's a lot of money. A lot of money. Okay? That you're almost going to pay double what you borrowed. Why? Because they can. Unless you've got $200,000 in your piggy bank, you have to borrow the money. Okay? Say when you buy a car, what's the car loans? How long do you get a car loan for?
3 years.
3 years? 4 years? 5 years? Now they've stretched it to 7 years. Some banks will give you an 84-month loan for your car. Okay? And then sell your car after 7 years old. You ever heard of depreciation? Yeah. Unless it's like a 4-wheel drive, or maybe a Honda or a Toyota, they hold their value pretty well. You probably won't get very much money for your car after 7 years. But they can do that because they can make it affordable by stretching the payments, stretching the years out. Okay? How about when you go put money in your piggy bank at the bank? You put money in the bank, how do you get paid? They give you interest, right? Most have a savings account. What's your interest rate? 0.5%, good answer. Half of 1%, and then how often do they give you money? You probably get it 4 times a year, they call that quarterly. For example, you have $100 in there, after 3 months, they give you a statement that says you have $100.12. Make it that number, you made 12 cents. And then 3 months later, your statement comes back, you have $100.27. So you made 15 cents because you have a little bit more money. Okay, and they do that 4 times a year. So that's called compounded quarterly. Okay, that's how the money works. All right. If we look at, let's say you have $1,000 today, you put it in the bank, $1,000, and they are going to pay you 10% monthly. How much will you have in the account at the end of 10 years? Let's just say that the amount's going to stay the same. You're guaranteed 10% a month for 10 years. Do some of you have like a savings bond or a CD in the bank? Where you put money in the bank and then you can't touch it for like 5 years? Those usually yield a higher percentage rate. Do you know why? You can't take the money home. If you do, you get penalized. Okay, so they own that money until 5 years is up. But they'll give you a higher percentage rate. Okay, let's see what happens here. Let's show you the math work behind it. How does the math work? Well, we're going to go A equals, what's my principal amount? What's that capital P in this one? Yeah, it's 1,000. And the rule says 1 plus, and what's it say? 1 plus R. What's R? R is the rate, but I can't compute 10% as the number 0.1. Okay, so B has up there. 0.1. Divided by, what goes on the bottom? N. N is the number of times the money is compounded. How many times? 12, right? Why is it 12, you guys? You're going to do it monthly, which is 12 times a year. We're going to raise it to the NT. What's that? 12 times 10. Now, I'm going to show you how to do this. Does the 12 times 10, does that apply to 1,000? It doesn't, right? Mathematically only pertains to the quantity. So do this. Go 0.1 divided by 12. Get equals. Add 1. Get equals. Raise that to the power of 120. Get equals times 1,000. Now, money always rounds up. How many cents is it? 5. Disregard the rounding rules. Money always goes up. So if you kept $1,000 in the bank for 10 years, and you were guaranteed 10% a month, and they compound it once a month, you would have made $1,707.05. Okay? Is that practical? Probably 10% a month for 10 years. Probably won't happen. Okay. 6 is a great problem. This is a great problem. I would ask you this on a quiz. Be able to do this problem. Let's say that you had $4,000 and you deposited it into an account at the bank, and you're going to get 10% compounded quarterly. Somebody else put in $5,000, but they're only going to get 6% compounded quarterly. When will the first account be worth more than the second account? In other words, when is the first person's dollar amount going to catch the second person? What has to be true of the first person's rate if this is even practical? It's got to be higher than 6%, right? If you're going to gain 5%, are you ever going to catch the 6%? No. What if it was 6.1% for the first person. Will you catch that person? Yeah, take a long time. So you understand the common sense of the problem? Let's do it like this. Let's just call it, the first amount is a sub 1. So let's go a sub 1, the first amount, is equal to, what's the principal? 4,000. And the rule says 1 plus, what's R? 0.1. Divided by 4, quarterly means 4 times. Raise it to the, what? 4x. Because x is divisible for time. How long will it take? A sub 2 is equal to, I'm going to put in 5,000. My rate is going to be, guess what students put in for that number? 0.6. It's 0.06, 0.06. Divided by 4 and raise it to the what? 4x. Now, once you've established the two different equations, I want you to put them into your graphing calculator right now. A sub 1, A sub 2, do that right now. I've left a screenshot so you can make sure you put it in just like I did. Notice I used double parentheses. Okay, you can never use too many parentheses. And then y sub 2 is the blue one. That's a sub 2. Now, what's x stand for? Time, right? What would x equals 0 be? Huh? Right now, right? 0 would be right now? Well, does that make sense? At 0, it's 4,000, 5,000. That's the day of the deposit. After 1 year, A sub 1 is 44,1530. A sub 2 is 5306. I haven't caught, right? But I'm making ground, right? I'm less than $1,000 difference. After 2 years, I'm about $800 difference. After 3 years, see what I'm catching? A sub 2. The question is, when will the first account have more money than the second account? Well, A sub 1, A sub 2 on my graph. When those two curves cross or intersect, what does that reflect? When they're the same. When they're the same. So go find that point. How do you do that? Second, calculate what? Intersection. Good. You guys gotta change. You guys gotta want to change the windows. You're asking it to graph like 5,000. What's it by default? Negative 10 to 10. Okay, you have to know how to change your windows on your calculator. Find the intersection point. Who's got it? What's that number? I have an arrow drawn for you. What number is it? Yep. Write that down. In 5.69 years from the day of the deposit, ace of 1 will equal ace of 2. That $4,000 deposit will have the same value as the $5,000 deposit. Why? Because the interest rate's higher. So it says, when will the first account be worth more than the second account? What's the answer? What? How should I say this? Do this for me. What's 0.69 of a year? 0.69 of what? What's 365? For days? We're just gonna be rough, 251.85. Therefore, after what? 5 years, and what should we say, 252 days. So like on that day, and I'll understand that we're rounding, but you get the idea. So somewhere on that 252nd day after 5 years, and 252 days, ace of 1's gonna pass it. Understand the math concept here? Okay? All right. The last one. Your visual for the day. You'll never forget this now. Remember the day that there was a bottle of shampoo put on the smartboard? The PERT formula. Okay? First hour said that there's no such thing as PERT shampoo. So I either go prove them wrong. Okay? It's been in my hair before. So I'm quite sure it was PERT. Okay? And it does still exist. You know what? See the PERT? Capital P, E to the RT. Okay? A is the amount, R is the rate, P is the principal, T is the time. This is for interest that is continuously compounded. Okay? So you have to be careful of what one you're using. Am I using compound continuous or am I not? Say it again? It'll tell you if it's being compounded continuously. Compounded continuously would be like every day your money's being compounded, or your interest is being compounded, versus once every 3 months or once every month. Okay, it's continuously. Okay? It's used in business, banking, and economics. This one. Okay? It says, if the principal P is invested at an annual rate R, compounded continuously, then the amount A in the account at the end of T years is given by A equals P E to the RT. The annual rate R must be expressed as a decimal. All right. Great example to end this. What amount will be in the account after 5 years if you put $1,000 in? And I'm going to tell you, you're going to invest it 3 different ways. You're going to invest it annually, which means what? Once a year, you're going to get interest back. Quarterly, 4 times a year, or continuously is what it is. Continuously. Look what happens to these values. Here we go. Annual. A equals 1,000. 1 plus, what's the rate? 0.12 divided by 1, right? once a year, raise it to the what? 5 times 1. You guys understand all the numbers, where they come from? Okay, compute that, what do you guys get? Just practice, remember to round money up. So it's 1.12 taken to the 5th power times 1,000.
62.35.
So Ben puts $1,000 in. He gets compounded once a year. After 1 year, he will have 1762.35 in the account. Quarterly. Same amount of money. What's the rate? Stays the same, right? 0.12 divided by what? 4 quarterly, raising it to the what? 4 times a year for 5 years. Okay, compute that one. Remember to do the parentheses first. Raise it to the 20th power. Take it times 1,000.
1,806.2.
How many cents?
12.
So far quarterly is better, right? About $44 difference. Now, continuously, now you have to use the purple. Capital P, E to the RT. Put the numbers in. What's P? 1,000. E is a constant. R is what? One, 2. T is what? 5. Here's how you do this one. Take E, put E in your calculator. Raise E to the what? Parenthesis 0.12 times 5. It equals, take it times 1,000. What do you get? 1822? Point what? 22. So your best value is to invest your money to be compounded continuously. Will they? Your worst case is to do what? Do it annually. So which one's the most common one? Quarterly. You'll get a statement from them every, what? How many months? 3 months, right? Happening 4 times. Okay? Any questions? What page is that assignment? Same page 397. Okay, here's the problems that you need to be able to do. 31 through 51 odd. Be able to do those. And then page 87 through, well, not page 87, number 87. 87 through 92 are some application problems with investing.